Okay, today we're going to get started with chapter 6. The first thing that we're going to go over, and this whole chapter is on what's called factoring. Okay, so what we're going to go over first, and we're going to just kind of do a little bit of a review on the division rule for exponents before we get into the greatest, what's called the greatest common factor. So let's just remind ourselves what happens when you are dividing the same bases. For example, if you have a problem like this, 6x to the 5th over 3x squared. If we are doing this division, that's what this fraction bar means, is this is dividing, okay? These numbers right here, you just divide like you always would. So here I've got a 6 over a 3, or 6 divided by 3, which would leave me with 2. And then what do you do with your exponents? You divide the top exponent minus the bottom exponent. So if I divide these, 5 minus 2 would leave me with x to the 3rd. So 6x to the 5th over 3x squared leaves me with 2x to the 3rd. Okay? Now, what we're getting into today in 6.1 is writing something in factored form. Okay, so we're going to have a list of terms, and we're going to look for what is in common with these terms. So I have x squared minus 2x. So we're looking at these two terms and looking for what is in common. What do you see in both of these terms? They both have an x. So they have an x in common. So that is called a common factor. So what you're going to do, since they both have an x, you can pull out that x, and then you're going to put in parentheses what is left. It's kind of like you are undistributing. You are seeing what was distributed to get these two terms. So we are pulling it back out now. So once you pull out the common factor, which is the x, what goes in the parentheses is what is left in each term after you pull out the x. And when you're pulling out the x, you're going to divide. So I'm dividing by exactly what I pulled out, which is x, each term. So let's see. Now remember that exponent rule that we just went over. If those are ones and I subtract my exponents because I'm dividing, what will be left here? I have x squared over x to the 1st, which leaves me with just an x, right? Because if you subtract those exponents, you'll have a 1. Minus, I'm just bringing that minus down. If I subtracted these exponents, I wouldn't have any x, right? I had an x, but I pulled it out. So all I'm left with is that 2. So here's your answer right here. When you pulled out the x, you were left with x minus 2. Now, here's the thing with the exponents, or with the x's. Let me show you something else. So again, if I'm looking at these two terms, they do have x's in common. But you want to pull out as much x as you can from each term. So let's see. What you do is you look at the exponents on the x's. This one's x to the 5th, and this one's x to the 3rd. You can pull out as much as the smallest exponent has. Okay? So if one has x to the 5th and one has x to the 3rd, then I can pull out x to the 3rd, however much the exponent has, the least one. So if I, again, remember, what are you going to do? to see what's left in your parentheses. Whatever you pulled out, which is x to the third, that's what you're going to divide by. So let's see, what am I going to do since I'm dividing the same bases? What do I do with these exponents? You're going to subtract them. So if I had x to the fifth over x to the third, that leaves me with x squared. Bring down my plus. I had x to the third and I pulled it out. So if I subtracted those exponents, I don't have any x's left. So all I have left is that 3. Okay, so that's like number 1. Those are both kind of resembled number 1. Let's look at a problem like number 2. You've got 6s squared plus 3s. So this time they're going to have more than just the s in common, right? Look at the 6 and the 3. What do they have in common? In other words, what goes into both of those that I can pull out? What goes into 6 and also goes into 3? A 3 does, right? 3 goes into 6 and 3 goes into 3, which means that is a common factor. It's a factor that goes into both of them. So I'm going to pull out the 3. What else do they have in common? This one has s squared. This one has s, which means if they both have an s, I can pull out an s. So if I pulled out an s, and I'm going to put in parentheses what is left. Again, it's very beneficial. Whatever you pulled out, that is what you are dividing by. So it helps to write that underneath what you're pulling it out of. So let's see, what is 6 divided by 3? Well, that is 2. If I subtract my exponents, and this one is a 1, s squared over s just leaves me with 1s. Bring down my plus. Now, look, you are dividing. I've got 3s over 3s, which leaves me with a positive 1, right? Anything over itself is 1. And then close your parentheses. All right, let's look at a problem like number 3. Actually, let's do another one like this to warm us up. Number 3 gets into something even more. So this time I have 3 terms. So what's in common is going to be in common with all 3 terms. So let's look at all 3 terms. Look at the number first. We have 5, 10, and 15, or 5, negative 10, and 15. What is the factor that goes into all 3 of those terms? Okay, if all 3 of them, they all divide evenly by the number 5. So I can pull a 5 out. Now, let's look at all the terms. What else do they have in common? They all have some amount of x. So remember, you can pull out as much x as you can. What you do is you look at all the exponents and then pull out whatever the smallest exponent is. So I've got x to the 5th, x to the 4th, and x to the 3rd. So the smallest exponent is x to the 3rd. So that's how much I can pull out. So that's what you're going to pull out. Put in parentheses what is left. How do you find that out? Whatever this is, that's what you pulled out. So that's what you're going to divide by. So if I'm dividing here, 5 over 5 cancels. Let's see how much x is left. If I had x to the 5th, and I pulled out x to the 3rd and subtract my exponents, I still have x squared minus 10 divided by 5 gives me 2. Here I've got x to the 4th divided by x to the 3rd. If I subtract those exponents, I'll still have an x. And the last one, plus 15 divided by 5 gives me 3. And x third over x third, those will cancel, right? If I subtract those exponents, I don't have any exponent left. Oh, close your parentheses, sorry. All right, number 3. This brings in something new. I have 2 terms here with things in common. If your leading term is a negative, you want to pull it out along with what is in common. So if I pull this out, I will pull out the negative. Now I have an 88 and an 8. So let's see, what goes into both of those numbers? The biggest thing, okay? 88 and 8 have several things that go into both of them, right? 2 does, 4 does, but so does 8, right? Since 8 goes into both of those, it is the biggest number that goes into both of them. So that's what I need to pull out is the 8. Here's my x's. I've got x to the 3rd and x squared. So if I pull these out, how much of this can I pull out? I've got x to the 3rd and x squared, which means I can pull out x squared, right? That's the smallest exponent. So here's what I pulled out. Let's see what is left. If I divide them both by what I pulled out, which is negative 8 x squared, right? Write it underneath each term. So negative 8x squared comes under both of these, okay? But because since you pulled out a negative, look what you're dividing now. You've got negative 88 divided by negative 8. So a negative over a negative gives you positive 11. And how much x do you have? I've got x to the 3rd and x squared. So if I divide that by subtracting these exponents, I'll be left with just an x, right? Now, here's what's tricky. What does a negative over a negative turn into? A negative over a negative turns into a positive. And look what you have. You've got 8x squared over 8x squared. You've got something over exactly itself. Or you've got this negative 8x squared divided by negative 8x squared. Well, if you divide something by itself, you are left with 1. Okay? Now, looking at number 4. (11x to the 4th minus 81. So let's see here. Looking at just the number part, I've got an 11 and a negative 81. Well, let's see what goes into both of those. With the 11, 11s are good numbers because there's only two numbers that go into 11 because it's prime. So 11 and 1 are the only numbers that go into this, right? Well, the only number they have in common is a 1. So if a 1 is in common, there's no reason to pull it out. 1 goes into everything, okay? Now look, this one has x to the 4th. Does this one have any x's? This one does not have any x's, so they don't have any x's in common either. Which means this is as simplified as this can get. There is nothing that you can pull out here. Okay? Nothing goes into both of these besides a 1. And if you pull a 1 out, you're still left with exactly the same thing. Okay? So these all have a B option. And this B option says there is no common factor other than 1. So that's what you would check on that one. That all they have in common is a 1. All right, looking at a problem like number 5. Two terms, right? Terms are separated by pluses and minuses. So here's my two terms, 8m into the 5th and 40m squared into the 5th are my two terms. So let's look at the number part first. We have an 8 and a 40. What is the biggest number that goes into both of these numbers? You've got 8 and 40. What goes into both of them? The highest number that goes into both of them is an 8, right? This is called greatest common factor. That's why you have to pull out the biggest number that goes into both of them. I know 2 goes into both of them, but if you pull out just a 2, you didn't pull out the biggest number that goes into 8 and 40, which is an 8. So after I do the 8, then let's see, do they both have m's? They do. So what amount of m do they have in common? This one has m to the first. This one has m to the second, which means if they both have m in common, I pull out the smallest exponent, which is m to the first. So I'm going to pull out an m. Do they both have n in common? The letter n. So n to the 5th here and n to the 5th here. So they do have n's in common, and the smallest exponent, since they're the same, is that n to the 5th. Put in parentheses what is left. Again, I definitely think you need to write what you pulled out underneath each term instead of just trying to eyeball that and do it in your head. Okay, so if I divide these by what I pulled out, which is 8m n to the 5th, divided by 8m n to the 5th. So let's see, 8 over 8, m over m, into the 5th over into the 5th. So do you have exactly the same thing in the top as you do in the bottom? You do. They are exactly the same. If you have exactly the same thing in the top and you're dividing it by itself, what are you always left with in that situation? 1, right? Anything over itself is equal to the number 1. Plus, divide here, 40 divided by 8 gives me 5. Let's see, when you divide your m's, you've got m squared up top, m to the first in the bottom. So if you divide that and subtract your exponents, you'll be left with m in the bottom, or m, sorry, not in the bottom. What happens to your n's? Into the fifth, subtract those exponents so you don't have any n left. So close your parentheses. Okay, looking at problem like number 6. You've got 32 p to the 6th cubed plus 24 p to the 5th q to the 3rd plus 56 p squared q squared. So this looks complicated, but just take it one small step at a time. So the first thing we're going to do is just look at the number part. So here we've got a 32. Here, I'm going to write this over here separately. So I've got a 32, a 24, and a 56. So if you have multiple numbers and you're having trouble finding the biggest number that goes into all of them, write them all out separately, and then go to your smallest one. So I'm going to 24. I want to see all the numbers that go into 24, which would be 24 times 1. What else? 12 times 2. Oh, I got a lot of numbers that go into 24. Let me spread this out a little bit more. 24 times 1, 12 times 2, 8 times 3, and 6 times 4. All those numbers go into 24, right? It's got a bunch. I want to find, and here's the reason I did them. I numbered them in biggest to smallest by making their factor pairs. So if I did 24 times 1, 24 would be the biggest, 1 would be the smallest. 12 times 2, so 12 is the next biggest, 2 is the second from the smallest, and so forth. So if you number them in their pairs like that and work in, your numbers will go from biggest to smallest down like that. And remember, you're trying to find the biggest number that goes into 32, 24, and 56. So let's see, the biggest option will be the 24. But does 24 go evenly into 32? No, it's too big. It's not going to go in there. So it's not 24. What about 12? So all you do in your calculator is say, okay, 32 divided by 12. It's going to give you some kind of decimal, right? So if this gives you some kind of decimal, then that means 12 doesn't go into 32 evenly. So that's not it. But when you do 32 divided by 8, it gives you 4. It gives you a whole number. That means 8 goes into 32 evenly. So now I just need to check the 56. Does 8 go into 56 evenly? Which means just in your calculator, do 56 divided by 8, and it gives you 7. it does go in there evenly, which means 8 is the biggest number that goes into 32, 24, and 56. So 8 is what I'm going to pull out and put in parentheses what is left. So I pulled out the 8. Now let's look, what else do they have in common? Do they all have P's? Let's see. There's some P, there's some P, and there's some P. So they all have an amount of P. So let's look. P to the 6th, P to the 5th, and P to the 2nd. So pull out what your smallest exponent is, which is P to the 2nd. Do they all have Q's? This one has a Q. This one has some Q, and this one has some Q's. So what's the smallest exponent on the Q's? Well, here's a 1. You can't get smaller than that. 3 and 2. So Q to the first is the smallest exponent. So here's what you are pulling out. 8 P squared Q. Now, remember, you always, always, always want to divide by what you pulled out. Let me see if this other red marker is. So what am I going to put under all three terms? I'm going to put 8 P squared Q. 8 P squared Q. 8 P squared Q. Okay, so if I divide all that, let's see what I'd have on this first one. 32 divided by 8 gives you 4. P to the 6 divided by P squared. Remember, you're going to subtract those exponents, so that gives you P to the 4th. And then what happens to your Q's? Since they both have 1 exponent, there's no Q left, right? You had a Q, but you pulled it out. So all that's left from this first term is 4P to the 4th. Plus 24 divided by 8 gives me 3. P to the 5th over P to the 2nd. Subtract your exponents, so that leaves you with P to the 3rd. And how much Q do you have left? Here, if I had 3, I pulled out 1. That means if you subtract those exponents, you have Q squared. And last one, plus 56 divided by 8 gives you 7. Let's see, I had P squared, but I pulled out P squared, so there's no P left. But here I have Q squared, and I pulled out Q to the first, so if I subtract those exponents, I am left with Q. Okay, I'm going to write another one up here that has a lot of terms like that, and then I'm going to pause for a second and let y'all work it. Okay, I'm going to try that one. I'm going to push pause on the recording for a second to give yourself. Okay, let's see what we can do with this one. So my numbers are 72, 36, and 24 again. So 72, 36, and 24. So again, the reason I go to the smallest one, because I feel like it won't have as many factors. Think about how many factors, how many ways there is to multiply to get 72. There's a lot of ways, okay? But here's the thing, if you go to the smallest one and write out its ways, then you're just checking to find the biggest one that goes into those other ones. So let's see, again, listing out the ways to get multiply to get 24. Now remember, I'm going to do the highest and the lowest. So 24 times 1. How else do you multiply to get 24? What's the next way? Let's see, does 2 go into it? Yeah, 2 times what? 2 times 12. Let's see, does 3 go into it? Yes, 3 does. 3 times 8 is 24. Does 4 go into it? Yes, it does. 4 times 6. And that's all the ways to multiply to get 24. So remember, you're checking starting from the highest because you're trying to find the biggest number that goes into 24, 36, and 72. So let's try 24 first. What do you get when you divide 72 divided by 24? You get 3, which means it does go into 72, but it also has to go into 36, right? It has to go into all of them. And what do you get when you do 36 divided by 24? You get 1.5. Which means it doesn't go into 36 evenly. So it's not 24. So where am I going to go try next? I'm going to try this 12. Let's see. Well, 72 divided by 12 gives you 6. So it goes into 72. Now let's do 36 divided by 12, which gives me 3. So it gave me a whole number, and I know it goes into 24, right? Because that's the only numbers I listed all go into 24. So let's see. 12 is the biggest number that goes into 72, 36, and 24. So I'm going to pull out a 12 as the greatest common factor. Now, let's see, do we all have x's? I've got x squared, x to the 5th, and x to the 6th. So I do have x's that go into all of them. So what's the smallest exponent? Here I've got 2, 5, and 6. So x squared is my smallest. What about y's? Do they all have y's? I've got y to the 5th, y, and y to the 3rd. So let's see, my smallest exponent is this 1 right here. So all I can pull out is a y. Put in parentheses what is left. So let's see, I'm going to divide everybody by exactly what I pulled out. 12 x squared y. 12 x squared y. And the last one, 12 x squared y. So let's see what I have left when I divide. 72 divided by 12 gave me 6. X squared divided by x squared. If you subtract those exponents, you don't have any left. So I'm going to the y's. I have y to the 5th over y to the 1st, which leaves me with y to the 4th. Moving along, plus 36 divided by 12 gives me 3. X to the 5th over x to the 2nd. Subtract your exponents, so that gives you x to the 3rd. And what do you get when you subtract the y's exponents? They both have 1, so when you subtract them, you don't have any y left, so no y's. Minus 24 divided by 12 is 2. X to the 6th divided by x squared. So if you subtract these exponents, you get x to the fourth. And what about your y's? I have y to the third and y to the first, which leaves me with y squared. And then close your parentheses. So here is what you would have left. Okay? Now, the second part of 6.1 is called factor by grouping. So it's in the greatest common factor section for a very good reason. I'm still going to be doing a lot of greatest common factor like I'm doing here. So I have 4 terms, right? 1, 2, 3, 4. I do look for a greatest common factor, always. That is what you look for every single time before you try to do anything else, is you look for what's in common with all the terms, because if they have something in common, you have to pull it out. So this one has a 7. This one doesn't have any number, so it essentially got a 1 and a 42 and a 6. So there's not anything in common number-wise with all, they don't all 4 have something in common. Do they all have M? This one does, this one does, but these don't. So you can't pull out an M because they don't all have it. Let's see, they all have N. No, this one does and this one does. But these 2 terms don't, so they don't all have an N. So there's nothing in common with all 4 terms. That is your clue that it is grouping. Factoring by grouping will occur okay? So your factor by grouping occurs when you have 4 terms and there's not anything in common with all 4 of them. That is your clue that it is factoring by grouping. And when it's factoring by grouping, the reason it's called factoring by grouping is because that's the first thing you're going to do. You're going to put the first 2 terms in a group. And then you're going to put the second 2 terms in a group. So you group them in smaller groups of 2. Now, here is why it's in the greatest common factor section, is because what I'm going to do now is just look at the 2 smaller groups and pull out what's in common just between the smaller groups. So looking at just these first 2 terms in the first group, what do they have in common? Well, they don't both have 7s, but they do both have an M. So I'm going to pull out an M. And remember, what you do is you put in parentheses what is left after you pull out the M. So how do I find that out? Just like we've been doing. Whatever you pull out, that's what you divide by. So let's see. If I divided this first term by M, what is left? Just a 7. Plus, if I took the M out of this second term, what is left? Just that N. So I pulled out the m, I put in parentheses what is left. Looking at the second group, they don't have any letters in common, right? This first one doesn't have any letters, but what's the biggest number that goes into 42 and 6? So remember our little trick. Whatever your smallest number is, write out the ways to multiply to get it. So 6 times 1 gives you 6. What is the other way? Let's see, 2 times 3. So those are all the numbers or factors of 6. So start with the biggest, right? Because you want the biggest number that goes into 6 and 42. Well, the biggest number that goes into 6 is 6. Does 6 also go into 42? Can you divide 42 evenly by 6? You can. When you divide 42 divided by 6 in your calculator, you get a 7. So it goes in there evenly. So that's what I'm going to pull out. Pull out the sign with it. So I'm going to pull out a positive 6. Put in parentheses what's left. Well, if I divide these both by positive 6, let's see what is left. Positive 42 divided by positive 6 gives me positive 7 plus, I pulled out the 6, right? If I divided that 6 out, the only thing that's left in this second term is that n. Now, this is not a coincidence. This is what is going to happen. What is left in your parentheses are going to be the same, which means they are now what is in common. And what can we do with what is in common? We can pull it out and then divide by it, just like we did here. M was in common, so I pulled it out, I divided by it, and put in parentheses what is left. So now the two things are being separated by this plus. What do they have in common? They just have a whole parentheses in common now. They've got that whole 7 plus n in common. So I'm going to pull it out, and then I'm going to divide by it, right? That's how you figure out what's left to put in your parentheses. So if I divide by 7 plus n, and put in parentheses what is left. So let's see. If I divided this first term by 7 plus n, that means I pulled out this 7 plus n, right? So if I pull this out, what is the only thing you see left? This m. Same thing over here. If I divided 7 plus n, divided by 7 plus n, that cancels, so what is left? Positive 6. And now you're done. So let's walk through these steps again. I've got 4 terms, but there's not anything in common with all 4 terms, which means I'm going to put them in groups of 2. When I put them in groups of 2, then I just look at the smaller groups and say, okay, what's in common just in the smaller groups? In this smaller group, the only thing that's in common is the m, so I pulled it out, open my parentheses, divided by the m, and put in parentheses what was left. So if I divided this by m, I'm left with 7 here, plus if I took out the m there, I'm left with n. Over here, I have a 42 and a 6. So over there, I found out 6 is the biggest number that goes into both of those. So I'll pull out a positive 6 and then do my division. 42 divided by 6 gives me 7. Plus, if I pull the 6 out of here, all that's left is the n. So now they both have 7 plus n in their parentheses. So essentially what's going to happen is these are the same. That's going to be one parenthesis of your answer. The other parenthesis of your answer is just going to be this combined with that. So the m plus 6 is your other parentheses. Okay, let's try another one, like number 8. HST plus 20T minus 10S minus 25. So I've got 4 terms. Nothing goes into all 4 of them, though. Almost, because 8, 20, and 10, 2 goes into all those, but this 25 messes it up, right? 2 doesn't go into 25. So I can't pull out a 2 because I wouldn't be able to divide that 25 by 2. They don't all have S's and they don't all have T's. So there's nothing in common with all 4 terms. What does that tell you? Factor by grouping occurs when there are 4 terms without anything in common. So let's put them in groups of 2. Looking at my first group, got 8ST plus 20T. So let's see, my numbers are 8 and 20. Let's see, let's use our smallest number, right? See how you multiply to get it. 8 times 1. Let's see, does 2 go into 8? Yes, 2 times 4. And that's it, right? That's all the ways to multiply to get 8. So what am I looking for? The biggest one of these numbers that also goes into 20. So does 8 go evenly into 20? When you do 20 divided by 8 in your calculator, do you get a whole number? You do not. You get a decimal. So it's not 8. Moving down the line, does 4 go into 20 evenly? It does, 5 times, right? If you divide 20 by 4, you get a whole number. So 4 is the biggest number that will go into 8 and 20. So I'm going to pull out a 4. Let's see, what else do they have in common? Do they both have S's? No. But do they both have T's? Yes, they both have T to the first power, which means I can pull out a T. Put in parentheses what is left when you pull out 4T. Again, write it underneath. 4T. 4T. So let's see what is left. 8 divided by 4 gives me 2. S. I don't have any S down here, so I'm not taking out any of the S's. I didn't bring out any S's, so I still have an S. I had a T, but I pulled it out, right? So the T's cancel. So I'm just left with 2S plus 20 divided by 4 gives me 5. T divided by T leaves me with no T's, right? If you subtract those exponents, you get nothing. So 2S plus 5. Now, remember on that last problem, what is left in this parentheses, when I pull what's in common out of here and put what's left over in the parentheses, it has to match this parentheses. So let's see, what goes into 10 and 25? Let's see, 10 times 1, 2 times 5. So let's see, 10 is the biggest number that goes into 10. Does 10 also go into 25? No. So moving down the line, does 5 go into both of these? Yes, it goes evenly into 10 and 25. Now, here's something where you've got to be extremely careful with your signs. Because if I just pull out a positive 5, think about that. What do you get if you divide this by positive 5? What is negative 10 divided by positive 5? Well, negative divided by a positive would make it be negative 2. What do I need it to be, though, to match this? It needs to be positive 2, which means what is going to change the sign? If I want this to be a positive 2, I need to divide it by negative 5, right? That negative divided by negative is what's going to change the sign. And here's kind of a clue. If you're looking at your second group, and your first term is negative, 9.5 times out of 10, you're going to pull out a negative along with what's in common. So 5 is what was in common, but I needed to pull out a negative to change the signs. So I'm dividing both of those by negative 5. So let's see, negative 10 divided by negative 5 gives me positive 2. I didn't pull out any S, right? There wasn't any S in common, so I couldn't pull out any S, so I still have the S. And what's negative 25 divided by negative 5? Well, that's positive 5. So 2S plus 5 now is what's in common. So remember, here's kind of a shortcut. You're going to have 2 parentheses as your answer. One parentheses is what is in common between these two, which is the 2S plus 5. The other parentheses are the 2 terms that you pulled out. Those 2 terms right there. So it's going to be 4t minus 5 is your other parentheses. All right, 2 more. Same thing, factoring by grouping. Nothing's in common all the way across. They don't all have Z's, because this last term doesn't. They don't all have A's, because these don't have A's. 5 almost goes into everybody. It goes into this one, and this one. But it doesn't go into this term, which means you can't pull out a 5. So there's not anything in common with all 4 terms, so we're going to group them. And just look at the smaller groups. Let's see, what goes into 5 and 25? 5 does. This one has Z squared, and this one has Z. So they have some Z in common. So you want to pull out the smallest amount of Z that you see. I've got Z squared and Z to the first, so all I can pull out is a Z. Put in parentheses what is left. So if I'm pulling out 5Z, that's what I'll divide by. And see what is left. I'm dividing by the 5's here. Here I have Z squared over Z, which means if I subtract my exponent, all I'm left with is 1Z, right? You subtract your exponents. Plus 25 divided by 5 is 5. I had a Z, but I pulled it out. So no Z's left in that second term. So remember, I'm going to have a leftover parentheses here too, and I need it to also be Z plus 5. So look at your signs here. They're both positives. These are negatives. So if I'm going to turn those into positives, that's what tells me I need to pull out a negative. That's what changes your signs in your second parenthesis. Since I need them both to change to positives in here so that they'll match those, I need to pull out a negative. What else do both of these terms have? They have an A. So I'm going to pull out a negative A. So that's what you divide by, negative A. So let's see, the negative over negative turns it positive. I pulled out the A. So all I'm left with is that Z. Again, negative over negative turns it to what? Positive. All I pulled out was the A, so I still have this 5. Do these match? Yes, so remember, you're going to have 2 parentheses. What the matching pair is going to be one of your parentheses. What you pulled out, which is the 5Z minus A, will be the other one. All right, last one, number 10. Nine m to the third minus 3m squared p squared minus 3mp plus p cubed. Again, nothing's in common with all 4 terms. So I'm going to group them. The first group, let's see, I've got 9 and 3. So what goes into both of those? What goes into 9 and 3? 3 does. Do they both have m's? They do. So this one has m to the third. This one has m squared, which means you can pull out the smallest exponent. So I'm going to pull out m squared. Do they both have p's? No, this one has a p squared, but this one doesn't have any p, so you can't pull out any p, right? In order to pull it out, you have to have it in common with both terms. So let's see, 3m squared is what I'm going to divide by. Let's see, what is left? 9 divided by 3 is 3. I had m to the third, I divided by m squared, so when I subtract those exponents, I get m to the first. Minus 3 divided by 3 just gives me 1. If I'm just left with 1, I have to write it, but if I'm left with 1 something, I don't need to write that 1. Is there anything left here? I pulled out the m squared, but I didn't pull out any p squared, which means I still have p squared here, right? I didn't pull out any p. Looking here, is my first term negative? Yes, I'm probably going to pull out a negative to change signs. They don't have any 3 in common, right? This has 3, but this doesn't have any number. This one has an M, but this one doesn't. The only thing that these 2 terms have in common is a P, right? And I can only pull out P to the first, right? Because this one has P to the first, and this one only has P third. So all I can pull out is negative P. So that's what you're going to divide by, negative P. Negative P. So when you're dividing by a negative, that's going to change your signs. This negative over a negative turns this to positive 3. I didn't pull out any m, so I still have this m, but I did pull out that p. What does this positive over a negative turn this into? You have a positive over a negative, which turns it to negative. P to the third over P to the first. So if I subtract my exponents, I have P to the second. And look, these match, which is what you want. If those don't match, something went wrong somewhere. These are set up to where they're going to factor by grouping, which means your parentheses are going to match. So remember, you're going to have 2 parentheses as your answer. The matching pair is one of the parentheses. So what's my matching pair? It's 3m minus p squared. What's the other parenthesis? It just comes from these 2 things right here. So 3m squared minus p. Okay, so we will do 6.2 and maybe 6.3. We'll see. I don't know. 6.2 is pretty important. So we might just do 6.2 on Thursday and push 6.3 to next week.